Hey guys, welcome back. Today let's solve the problem, add digits. So in this problem, given an integer num, our task is to repeatedly add all of its digits such that the result has only one digit. So if we're given an example of 2 digits, 38, what we can do is to take the 2 digits 3 and 8 and add them together. This will result in 11, and once we have 11, we can split the 2 digits again because our solution requires us to return a single digit number. Once we split the 2 digits, we'll be having 1 and 1, and the sum of these 2 digits will be equal to 2, which is the result as you can see in this given example. For this problem, we have a constraint that we should not be using a loop or a recursion, and I'll be showing you the most optimum solution, which will give you a time complexity of O of 1. How can we approach this problem? The first thing that we need to notice that whenever num is 0, if we ever take 0 added to any other 0, the solution will always be 1. So if the given num is equal to 0, then our solution will pretty much be equal to 0, which is a single digit number. The second thing that we need to consider is the divisibility of 9. And by divisibility, you will see that whenever we have any given digit that is divisible by 9, say 9 itself, 18, 27, 108, or any other number, the sum of all of its digits will always be equal to 9. 9 itself will be added to 0 to equal 9 itself again. If we consider 18, the digits are 1 and 8. If we take the sum of the 2 digits, we'll always have 9, which is 1 plus 8. 27 is the same case, 2 plus 7, which will always be 9. 108, it's 8 plus 1 plus 0, which will be, or this should be an 8. And the sum of this will be 1 plus 0 plus 8, which is also equal to 9. So what does this tell us? How can we use this to solve part of this given problem? We can notice this pattern whenever we take any given value like 108, 27, 18, or 9 and do a modulation with 9 itself. So if we take any given value that is divisible by 9, or that is a multiple of 9 like 108, 27, 18, 9, or any other value, and we modulate it with a 9, the result will always be a 0. So if we ever encounter such a scenario, then we clearly know that the sum of the digits, as we've proven just above, the sum of the left hand side digits will always be equal to 9. So this is the second case. Now what about values that are not divisible by 9? How do we handle them in our code? In the case where we have values that are not divisible by 9, so I have 3 different values like 11, 23, and 199. If we modulate with 9, the remainder will always be equal to the sum of the 2 digits or the 3 digits forming the given number. So as you can see, 11 modulus 9 will give us 2, which is also equal to the sum of the 2 digits 1 and 1. Again, if we take 23 in this case and modulate it with 9, the result will be 5. If we add the 2 digits, the result is also equal to 5. In the case of 199, as you can see, 1 plus 9 plus 9 will equal to 19. And from 19 here, we can take 1 and 9, add them together, this will result into a 10. And then for this 10, we can take its individual digits, which is 1 and 0, and the result will always be a 1. That is why we have a 1 in this spot. So the rule in this case is that whatever remainder we have when we take a number and take its modulus with 9 will always be the sum of these digits of the number, but it will always be less than 9. As you can see, any number that is less than 9 is always equal to a single digit. So with these 3 cases, we can be sure that we can compute any given value to its single digit without using any kind of recursion or loops in an O of 1 time complexity. Let's jump on the code and you can see how we'll do this. If you can remember, the first condition that we need to check is whether this given number is equals to 0. So if we check if the number is equals to 0, then we will simply return 0 because that is the default solution. The second case that we need to check is whether if we take the number and modulate it with 9, the result is 0. In this case, it must mean that the sum of the given number that we have is also equal to 9. So this is assured. Otherwise, if these two base cases are not executed, we can simply return the remainder of taking the number and modulating it with 9, and we can be sure that 1, this result will always be less than or equal to 9, and the result will represent the sum of the digits in this number simplified as per this given solution. Let's run the code and see if it works. And as you can see, it works and the code is pretty efficient. If you enjoyed this session, please like and subscribe, and I will see you in the next one.